Okay, so for shaded again, I just kind of want you to make sure you understand and do subtraction. I'm taking the larger. The radius of the larger was the 8 centimeters. I mean, we do understand that if this is 5, there's no way that is 8. That's 5 too. This would be 3, so the whole thing would be 8. So basically, pi r squared. So I'm just going to do 64 pi. That's the large minus 25 pi. Because both of these have pi, they are what we call like terms. They have to have the same variable, same radical, radicand, however you want to call it, to be able to add or subtract or combine them. So now I can subtract these. So this answer was 39 pi, and it's centimeters squared. Here, this is the composite. The shaded is the whole thing, so we're just adding up the parts. I thought it was faster to do the trapezoid by drawing this segment here, which I know is 4, and then that's 3. So the rectangle, I can automatically see that's 3 by 4. And then I see my base at the top, base at the bottom. Get my height, I'm adding these together. So my height would be 8. So base 1, 7, plus our base 2. The base of the bottom, remember this is 3. If the whole thing is 13, that means the remaining base is 10. So this is 7 plus 10 times 8, the height, divide by 2, or 1/2 of that, plus the 3 by 4. So this ends up becoming 17 times 8 divided 2 plus the 12, 68 plus 12. And this was 80 centimeters squared. So that's that. These are not test-like. Composite, yeah, but not really. All right, unshaded is kind of like the shaded. If I want to find what's remaining, I'm still going to subtract. So we need to find, break it into parts. I'm going to go ahead and just cut this here. I know this would be 4. That's 4. So this is a 4 by 4. And then if I look here, this is 6. This part is 4 here, this little distance, and then 4 here again. So that means this whole is 8. So basically, I have my 4 by 4, my small little square, plus my 6 by 8 rectangle. That would take up the whole space, okay? So 16 in the 48. And then I take the shaded part, the shaded rectangle. That's my 2 by 4, which we know is 8. So basically, 16 in the 48 is 64 minus my 8, which gives me 56 meters squared. Okay. The shaded is half the whole. Okay, this is it's fourths if I do it, but 2/4 is pretty much a half. So the whole thing is 16 by 16, or 16 squared, 256. Half of that. Basically, I'm taking half of 256, 128 centimeters squared. So that takes care of those two. The next part, 21, this is the test like you are definitely going to see a hexagon. There are some facts to a hexagon you need to know. One of the things we should recognize, and I kind of drew it here, but I'm going to draw it again, is that if in a hexagon, only in a hexagon, the side is the same as the radius. Okay? In a hexagon, only in a hexagon, the apothem creates a 30, 60, 90 triangle. The apothem always bisects the side, so this is 8 and 8. This is the short leg. The long leg is going to be 8 radical 3. So only in a hexagon, does this work. The apothem is half the side, okay, square root of 3. Or you could say it's half the radius, whatever the radius is. Take half of it, and then put square root of 3. You're going to have a special right always with a hexagon, okay? So I know my apothem is 8 radical 3. I got to do my perimeter. Perimeter is my distance around. There's 6 sides times 16. That gives me 96. So I'm doing 8 radical 3 times 96 divided by 2. Then minus the square, which is 16 squared. Well, I can just simplify this. Half of 8 is 4 times the 96. This is 384 square root of 3 minus 256. And this is my exact answer. These are not like terms, okay? The approximate answer, if I put it in the calculator, is 409.1. You will definitely see a hexagon. Make sure you know all the parts of the hexagon. Study your color paper that we put in the spiral. Okay, study the guided practice that we did. There was 4 problems that dealt with special rights that we did as well. Study your spiral. All right, shaded, we're going to subtract. This is a square, it's a 10 by 10. It's the equilateral triangle. A fact about an equilateral triangle is that all the sides are 60, so the height is always going to cut it into a 30, 60, 90. That's just a fact that you need to know by now. So if I do the area of the triangle, that's base times height, well, this becomes 5, and the height now becomes 5 radical 3. So my base is still 10 times my height, 5 radical 3, divided by 2. Area of a square is just 10 squared. So we know that that's going to end up giving me 100 minus 25 square root of 3. And that is my exact answer. When I plug it into the calculator, my approximate answer is 56.7. 22 is also test light. 23 is test light. You will definitely see some type of equilateral triangle. So they gave us the radius. Fact that you need to know with the equilateral triangle. To get to the vertex angle, we always end up taking the 360 divided by the number of sides and then cut that in half. But if I'm doing equilateral, this is always 60. This over here is always 30. It's kind of like the inverse of the hexagon. So we are doing the area of the circle minus the area of the triangle. Circle is just your pi r square. I see my radius right there is 10, so we got 100 pi. Area of a triangle, for this triangle, because they gave us the radius, I want to get to my apothem, which is the segment from the center to the side. I know this is 10, so the short leg is half the hypotenuse, so it's 5. To get to my long leg, it is the short leg times radical 3, so this is 5 radical 3, 5 radical 3, which means the whole side here is 10 radical 3. Please understand that's the side. I'm not talking about the curve. So I could do apothem times perimeter divided by 2 if I'm going to use the radius part, or I have to actually draw the height if I'm going to do base times height divided by 2. We're going to do this. So the apothem we already know. So we got 100 pi minus 5. Perimeter, that would be 30 square root of 3. If each side is 10 radical 3 times 3, that's 30 radical 3. Then we're going to take half of that. So that ends up becoming, yes, 75. So 100 pi minus 75 square root of 3, that is the exact answer. If I put in the calculator, that's approximately 184.3. Okay. 24 is not really a test like, but can you problem solve and see that this is getting broken down by 6 by 6? So understanding that aspect, I might use that in a problem, 6, 6. Then I'm hoping you see that the legs are congruent, so the hypotenuse is 6 square root of 2. So if I want to find just the shaded, because the shaded is the square, I'm trying to find that square. So that's just the square, the side of the square. So the side of my square is 6 square root of 2. If I square that, I am squaring the 6, and I'm squaring the square root of 2, the radical 2. When I square 6, that's 36. Anytime I square a radical, gets rid of the radical, so we have 36 times 2, and we have basically 72 centimeters. Now, some of you might have took the whole and subtracted. Okay, since the shaded is a square, I'm just going to do that. All right, that takes care of that page. Fast forward to the next.